Okay, this video is to go over the basic functions of our GFG 8215 alpha analog function generator. You're going to need this function generator for lab 14 and 15 and our labs that follow beyond that as we study AC signals and RF frequencies. So before you get started, you're going to want to first set up and calibrate your oscilloscope, and you're going to need to find your BNC to alligator split. We're going to take this BNC British nipple connector and line up the notches with the output setting here. We got a preloaded 50 ohm output on our function generator. I'm going to slide this in there and give it a quarter turn until it locks. Okay, and then looking at your function generator setup, you have a frequency knob and a set of multiplication values across the top, and then this particular function generator has 3 function waveforms as well as an attenuation button there. Okay, we're going to start with all of our knobs turned to the minimum. We're going to turn them fully counterclockwise until they stop, and we're going to set this circuit up with the circuit you need in lab 15, exercise 24. This will be the load that we'll go over these basic functions with. So this is a simple series circuit. We have a 10k ohm resistor in series with a 1k ohm resistor, and we're going to take the positive lead and turn that on the 10k side, and we'll take the ground or negative lead to the 1k side of our circuit. Okay, and we can take our oscilloscope probe here, and we're going to first look at the entire circuit signal. So we'll take the ground lead on the negative side and the probe on the positive side there. We're going to look at the signal going across the entire circuit. Now as we get started, let's go ahead and turn our function generator on, and they're calling for a 500 hertz waveform. And so when you turn this on, it defaults to the 1K setting here. Now 1K times 0.5 should give me a 500 hertz. So right now we'll eyeball this. We're going to adjust our knob to about the 0.5 setting, and we're going to put a sine wave. So change your function there to a sine wave. We're going to give it a sine wave output, and let's look at the frequency that we get on our screen. I'm going to give this a little bit of amplitude. They do call for an 8-volt peak-to-peak waveform. We'll adjust that exactly in a minute. Okay, but we'll give this signal a little bit of a amplitude to it. Now, since we are 500 hertz, let's think about what our time per division setting should be. At 500 hertz, we can look at a 0.5 millisecond per division, and we should be able to calculate the signal that we have here on the screen. And really what we're looking for is, if it's 500 hertz, it's going to take us 2 milliseconds to complete a whole cycle. So we can fine tune our signal here so that we are seeing exactly as we adjust. I just adjusted the frequency knob there, so we are seeing exactly 500 hertz. Now I can change the trigger level if I need to.